We're going to take a couple minutes here and we're going to work on fraction rules. So something that you learned in elementary school, and most people are using calculators at the secondary level, and we find that we forget some of our basic rules that we learned from not using them. So it's really important that we take the time to review our rules of fractions, because as we're working with rational expressions and our polynomials, we'll be getting into some fractions. So first we're going to start with multiplying fractions, and then we're going to get into dividing, adding, subtracting. So to multiply two fractions, we multiply the numerators, we multiply the denominators. So we multiply across the numerators and across the denominators. So you have a over b times c over d, just a general idea here, and that would give us a times c over b times d. We don't want to get multiplication confused with cross multiplying, okay? So I have here, if a, b, c, and d represent numbers, b and d cannot be 0. So if we have that up there, a over b times c over d, the reason b cannot be a 0 and d cannot be a 0 is the idea that that is a domain restriction. And as we move forward, that is something we are going to talk about. It's a domain restriction because we cannot put a 0 in, because we cannot divide by 0. All right, side note here. So we are multiplying fractions across the top and across the bottom. We don't want to get confused with cross multiplication. A lot of times that does confuse people and they think about it. If I'm using cross multiplication and I have a over b equals, that's the big deal, c over d. That's what's different. A over b is equal to. Cross multiplication is when you have an equal sign. And then we do cross multiply. We take the a times d, and that is equal to b times c. Cross multiplication is truly a shortcut for multiplying out. If I wanted to get rid of the divided by b, I multiply both sides by b. It cancels out and it's over here. And to get rid of the divided by d, I would multiply both sides by d. So cross multiplication is a shortcut to eliminate denominators, but that only works if you have an equal sign. And we have no equal signs. We are just multiplying fractions. The other option you have, so cross multiplication is not what we're doing now, but when you're multiplying fractions, you may cross cancel. And that is a skill we're going to use. Some people use the term cross cancel, some people use the term cross reduce, but we will be reducing our top and our bottom. Okay, so let's go ahead. It says multiply and simplify. So the first thing you might do is you might just jump in and multiply across the top. 3 times 5 is 15. And we have our 8 times 7, which is 56. But I have to make sure that if it can be reduced, I reduce it. So I'm going to look at my common factors. 15 doesn't go into 56. 5 doesn't go into 56. 3 does not go into 56. So this doesn't reduce. That is my final answer. The other way that I know that it wouldn't reduce is if I go back to the idea of cross-canceling. The numerator and this denominator do not reduce, and 5 and 7 don't reduce. But I'm also going to look to see if I can cross-cancel. Any numerator can cancel with any denominator when we have multiplication here. All right, so same idea. Nothing reduces to begin. There's nothing that will cross-cancel, so I end up with just 1 over 18, and that is my final answer. I know that we could do these in a calculator, but we're practicing our multiplication skills on fractions because we're going to need that later with variables and equations that we won't be able to use a calculator for. Okay, so if I look at this and you jump right in, I have to take 6 times 5, and that's 30, no problem. Then I have to take 55 times 8. So I'm going to have to either work for it or use my calculator. And then once I get that big number, I have to reduce it. So I like to avoid that. And what I'm going to do is look, the 6 and 55 don't reduce, and the 5 and 8 don't reduce. But the 6 and 8 do. So why am I allowed to cross cancel? Well, if I use my rule that I'm multiplying the numerators and I'm multiplying the denominators, if we went through this, just to show it, and I multiply the top, multiply the bottom, and then I use my property, my commutative property, and I flip-flop and make it 8 times 55. And now you see, if we split this up, 6 and 8 have a common factor of 2. So goes in there 3 times, 2 goes into 8 4 times, and 5 and 55 have a common factor of 5. So 1 and 11. So my final answer is 3 over 44. I don't have to do all of this rewriting. I just want to show that I multiply the tops, I multiply the bottom, and if I flip-flop, you can see the 5 or the 6 over 8 and the 5 over 55 would be fractions that we could reduce. I prefer just to start up here. 6 and 8 cross cancel, so 2 goes into here 3 times, and 2 goes into here 4 times, and then 5 and 55 cross cancel, so 1 and 11. And you just multiply across the top, and there was the 3 we had, and the bottom, which is 44. So it's really important to be able to use that skill of cross canceling. I know we could just multiply and reduce at the end, but cross canceling makes it a lot easier, and we need that skill for later to understand. All right, so a couple more problems. We'll move through these a little quickly. 4 and 8 reduce, so we want the GCF to divide out. I like to sort of show what's left. And then 3 goes at itself 1 time, and it goes into 15 5 times. So we get 1 over 10. Final answer. All right, now this is changing and getting a little more abstract. So we're still following our rules, but you can see I have variables introduced here. So whether the 1 was here or not, it's understood, but the big idea is when I take this times a negative, my answer will be a negative. So I'm going to start with that. Some people like to rearrange it and clean it up. Some people like to start canceling. Nothing cross cancels. 1 doesn't cancel with 2 or 28. 11 does not cancel with 2 or 28. So I have nothing to cross cancel with numbers. So if you look at this and I multiply, I have 1 times 11, so I've got my negative there. And it's 11a to the 6, because we multiply the bases, we add the powers. And in the bottom, I end up with 56a to the 3rd. Try that again. And with 56a to the 3rd. So there's something that does reduce. Even though the number doesn't reduce, do you see that I have an a in the top and an a in the bottom? So just like in prior topics, we would use our exponential properties and we would take the 6 minus the 3 and we have a to the 3rd left over, or cancel 3 of these and there's 3 left over. So my final answer is negative 11a to the 3rd all over 56. Now your other option, some people like to clean up all the a's. Some people will just come in here and cross out 3 and cross out 3. They'll have 2 left and then they'll have their a to the 3rd. So you could do it all in one swoop from the top, or you can clean up your variables. When we have a problem like number 6 here, there's a lot of variables. So again, some people will come in and cancel this x with that one and do that. For some people, it's better to clean it up at the end. So I'm going to go ahead and reduce my numbers. That's a 1 and that's a 4. Double digits, 11 goes into itself once and it goes into 33 3 times. So number-wise, I have 3 over 4, just multiplying the leftovers. If we clean up our variables, I have x to the 6 and a y, and then I have x to the 3rd and y to the 2nd. So again, you don't have to do it this way, but for some people it really helps, and I'm going to clean it up. I keep my 3/4. There are more x's in the top, so I'm going to knock out 3, and there's 3 left up top. And I have y to the 1st and y to the 2nd. And that's important that we recognize that if I would subtract 1 minus 2, I'd get a negative power, so I'd have to put it on the bottom. Or I like to cancel out 1 there, and there's 1 left in the bottom. So you do have to watch where your variable is left over. Okay, now, this number 7 has no variables, but we do have 3 pieces. So a couple things. First of all, multiplication is commutative, so it doesn't matter what order I multiply in. And second, we don't have to rearrange it. We can just multiply or cross cancel from any top to any bottom. So if the 25 and the 6 reduced, I could do that. I don't have to show the rearranging. So any top to any bottom. So the 3 goes into 3 once and it goes into 6 twice. And I can reduce the 25 into 10. So 5 goes in there twice and it goes in there 5 times. And so I just multiply across the top. 1 times 1 times 5 is 5. And in the bottom, I have 2 times 2, which is 4, times 16, and I get out 64. Now, in case I missed something on all of these problems, I should double check at the end if I missed reducing something. All right, number 8 has 3 terms, well, 3 pieces that we're multiplying, and we have a lot of variables. So this is one that you might want to clean up first, but I still like to reduce the numbers. That way I don't have a big number to reduce later. So let's go ahead with this whatever you see. Like someone might reduce the 21 and the 12. 3 goes into 21 7 times. 3 goes into here 4 times. Someone else might see this as the 5 and the 20 next. So again, 5 goes in there once, that goes in there 4 times. Now, you have a couple options. It always has to be top to bottom. So one person might reduce the 6 and the 4 by 2. Someone else might reduce and knock out the 4 with the 4. So that's gone. And then the 6 with the 3. So again, this can be done differently. It can be done in a different order. Across the top, I have just 14. And in the bottom, I'm left with just 1. Now, I still need to do my variables. So I have x and I have y to the third. And down here, I have x squared and I have a y. So if I'm cleaning this up, I keep my 14. I don't have to keep my 1 in the bottom. X is going to be left over down there. So that'd be x. And then y cancels with that. So I have y to the second up there. And that is the final answer. So that is multiplying and using cross canceling. So the next thing we're going to look at is division, but we're really not going to divide. We are always going to multiply by the reciprocal. So when you have this, it says two numbers are reciprocals of each other if their product is 1. So the reciprocal of a over b is b over a. Because if I take a over b times b over a, these cross cancel, and I'm left with 1, or AB over AB. So if you would like an example, and I have 5, then its reciprocal would be 1/5, because remember we can put that over 1. And that gives me 5 over 5, which is 1. So we're not changing the sign, we're just taking the reciprocal, changing the fraction. Now, this is a key idea here. We are never going to divide two fractions. You're always going to multiply the first one by the reciprocal of the second. So if you have a over b divided by c over d, there's nothing you can do with division. You don't cross cancel, you don't do anything with division. The minute I see dividing by a fraction, I leave the first piece alone, and then I multiply by the reciprocal of d over c, or d over c, and I get AD over BC. So I would also look to see if I can cross cancel, but you can only cross cancel with multiplication. And these rules seem so straightforward and so easy when you are working on just multiplication, just division, just addition, just subtraction. But when you have a mix of problems, it's really actually easy to mix up your rules. So it seems very easy now, but if you try to do a mixed worksheet, that's sometimes when you forget something. Okay, so I cannot reduce that 14 and 2. Absolutely not. It is division. You don't touch division. You leave the 3 halves alone, and then you're going to flip the sign, right? The inverse of division is multiplication, and you're going to flip the fraction to 5/14 or the reciprocal. Now, I still look to see if I can cross cancel, and nothing reduces. So I get 15 over 28. Okay, looking at the next one, same deal. I'm not even touching it. I'm not even trying to cross cancel. I'm going to leave the 8/7 alone. It's important that you leave the first fraction alone, and then you multiply by the reciprocal. Okay, this one I can cross cancel. So the 2 reduces with the 8. And that leaves me 4 times 9, which is 36 over 7. And again, every time I do this, I am double checking that these don't reduce any further, because maybe I missed one of them. All right, in 11, it really looks like we want to cancel out these x's and reduce the 4 and the 2, but we cannot because it's division. So you may only cross cancel with multiplication. So we're going to leave that 4 over 9x alone, and we are going to multiply by 2 over 1x, or 2 over x. Now, 4 9's 4, nothing's cross canceling here, so I'm left with 8 over 9x squared. 8 over 9x squared. Okay, now we're getting into some more variables, but what's really nice about division is you're not doing anything harder than multiplication. So we're going to leave this alone. Actually, if you wanted to, you could sort of clean this up. So I'm going to go ahead and do that. I'm going to knock out these x's. I'm going to knock out and leave one of the y's there. So I have 10x squared over 4y to the first. Okay, and again, you don't have to do that first, but I thought maybe I would do that. I guess I could have reduced the 10 and the 4 also, because it's in one fraction. Okay, and I'm going to multiply by the reciprocal. So the 9's going to stay there. I'm going to knock these y's out. And then the bottom now is going to be 2x squared. So again, if that bothers you, go ahead and just take the reciprocal first and then start canceling. Now, it's up to you. You can cancel the 10 and the 2 or that 10 and the 4. It works out the same. I'm going to go ahead and do this. Don't forget, you can always reduce top to bottom. And what's left is a 45 in the top, a 4 in the bottom. And then let's look at these variables. The x squared cancels with that x squared there. And really, we're only left with a y in the denominator. And that is our final answer. Okay, so we look at these bottom examples, and they look a little bit different. But I need to remind you that this is still a division sign. But I need you to look at this as a fraction of 1/8 divided by a fraction of 3/4. And we don't divide fractions, we multiply by the reciprocal. So I leave that numerator of 1/8, and I'm going to multiply by the reciprocal of the denominator, which is 4/3. And now I can cross cancel. So I think it's much easier to see these problems if we take them from being a vertical division problem, multiply by the reciprocal, or, you know, you could have rewritten as 1/8 divided by 3/4. And then you really see that you are flipping the fraction after multiplying. So our answer is 1/6. Same idea here. I'm going to take the numerator, 14/5, and I'm going to multiply by the denominator, which is 5/7. And then this is going to cancel, and this is going to reduce, and I'm left with just a 2, or a 2/1. And that is it. Okay. Now we're getting some variables here. So I'm really not going to do anything until I start. So I'm going to go ahead and I'm going to take my 2x over 27y to the third, and I'm going to multiply by 9y squared over 4x squared. Okay, so my division turned to multiplying by the reciprocal. You always want to double check that you really did flip that and you didn't miss anything when you rewrote it. Okay, so now I'm going to go ahead and cross cancel. The 2 and the 4 reduce. The 9 goes in there once, it goes in here 3 times. So at this point, I'm okay. I'm going to knock out my x with one of my x's, and these 2 y's with one of these. And a little bit messy, one of the mistakes that people make is they will put the answer as a 6xy. And there is a problem with that, because if I have the 6xy, I got it wrong, because the 6 and the x and the y were in the denominator. So there should be a 1 on top. So be really careful with where it's left. Okay, we have one more of these to try, and that will be the 9p squared q over 5p to the third. And I'm going to multiply by the reciprocal, which is 10pq squared over 21q to the fourth. All right, so now that I have that, I'm going to start cleaning it up. The 5 and the 10 reduce, so 1 and 2. The 9 and the 21 reduce, so 3 and 7. And then I'm going to double check that there's nothing else reducing, so number-wise, I'm left with 6/7. Those are my numbers. And then I'm going to look at my variables here. If you want to clean it up, you can, but I'm looking to have 1, 2, 3 p's up here, and there's 3 down here. So p is going to cancel completely. I have 3 q's up top, if I put them together, and I have 4 down here, so I'm going to have 1 q left, and notice it's left in the denominator. All right, so that is a great review of multiplying and dividing fractions. So the next thing I would like to continue and show you, which is actually a little harder, is adding and subtracting fractions. And the reason it's harder is because of our denominators. So honestly, multiplication and division are the easy things to do with fractions, and this is a little more time consuming. All right, so we're going to start off. If we have A, B, and C are numbers, and b is not 0, then a over b plus c over b is equal to a plus c all over b. And remember, b cannot be 0. So whenever I add or subtract, to add or subtract fractions with the common denominator, I simply add or subtract the numerators, and then I keep the common denominator. Now, if I don't, all right, so if you don't have a common denominator, then you have to build one, and that's what makes it a little bit harder. So we're going to start off real simple. There is no cross canceling. You are just going to add. So if you look here, I have a common denominator of 8, and then 5 plus 1 is 6. And then once I add my like terms, that's when I'm going to reduce. And they both have a common factor of 2, so I would end up with 3 over 4. All right, here I have a common denominator of 11, and so I'm going to go ahead and do my addition subtraction. So 10 minus 1 is 9, plus 7, and I end up, 10 minus 1 is 9, plus 7. I end up with 16 over 11. Now, this answer doesn't reduce, so I would just leave it alone, but you could make it a mixed number of 1 and 5/11. All right, our next step is going to be adding and subtracting unlike fractions. So this takes a little more effort. First thing you want to do is find the least common multiple of the denominator. All right, so the smallest common multiple in the denominator. And then you're going to write each fraction as an equivalent fraction whose denominator is the LCD. I like to remember that you have to change the top and change the bottom. And then you're going to add or subtract the like fractions and write the sum or difference again in simplest form. So the new part, the big step, is getting the common denominator. So you can see that I have a denominator of 6 and 18. If this was multiplication, I would cross cancel, multiply out, I'm all done, or just reduce. But this is addition, so I have to have a common denominator. So with 6 and 18, the least common multiple is 18. To get that, I'm going to multiply this by 3. And whatever I do to the bottom, I have to follow and do the same thing to the top. Because it's like our little loophole. 3 over 3 is the same as 1. And the multiplicative identity allows me to multiply by 1, and it doesn't change anything. So I'm changing the form of it. So multiplying the bottom by 3 gives me the 18, but I have to balance it by multiplying the top. So I really have 3 over 18 plus 3 over 18. And I keep my common denominator, and I add my numerator. So I get 6 over 18, and I do want to reduce that. So my final answer, they both divide by 6, is 1 over 3. All right, so we keep moving forward here. I have a 6 and I have a 9. I can't multiply 6 by a nice whole number to get 9. So I'm going to have to build them both up. So the next common multiple they have is 18. So knowing my times table is really helpful in this situation. So multiply this by 3 and multiply that by 3 and multiply this by 2 and that by 2. So in the top, I get 15, and then down here I get my 18, my common denominator, minus 4 over 18. If I took a minute and reduced the 4 over 18 divided by 2, I'd go right back to my 2 9s. If I reduced and divided out the 3, I'd go right back to 5 6. So we're actually building these up to get a common denominator, and I'm left with 11/18. So just a little bit of extra effort to get a common denominator. All right, one of the things I want to bring up about number 21, when we had the subtraction sign in the middle, we knew to take the numerator minus the other numerator. I sometimes like to rewrite this sign and put it up in the numerator so it doesn't get lost. So negative 1/5 is the same as negative 1 over 5. It is also the same as 1 over negative 5. I prefer to keep my negative sign in the numerator for most problems. All right, so I'm going to go ahead and get a common denominator of 20. If you go too high, that's okay. You'll just have to reduce later, and it makes your numbers a little bigger. So finding the least common multiple is just easier. All right, so let's go ahead and set this up. We have 4/20, and then we would add to that, we have 15/20. And I have my common denominator, and I end up with 19/20, which is almost one whole. And I totally forgot my negative sign, so let's fix that. I don't get 19/20. So that is exactly why I said in the beginning that I want to move my negative sign so I don't forget it. And as I built my fraction, do you see that my negative sign ended up looking like a fraction? So I really should have put my negative sign there. I lost it. So it's negative 4 plus 15, which is 11. So exactly what I was telling you to watch for so we don't lose it, I lost it. All right, now what's different about this one is we have an x in the denominator. So again, maybe you do addition of the opposite. You don't have to, but that might help you. 12 and 24, I would need to multiply this by 2. Now that gives me the 24, but this has a 24x. So I need to build that piece. So I'm going to multiply this by x, and if I do it to the bottom, I also multiply the top by x. So I have a 14 over here over 24x minus or plus the negative 5x over 24x. When I go to put this together, I keep my common denominator of 24x, but my numerator, they're not like terms. So it is going to be simply 14 minus 5x. And that is all I can do with that because they are not like terms. All right. We have a couple more problems on the back. You can see that we start getting into some fractions with variables. Again, you might want to change that, but I need a common denominator. There's no cross canceling. You can't knock out the y's. You're adding and subtracting. So again, maybe you don't want to, but you can change that so you don't lose that minus sign. That will help later when we're dealing with rational expressions and equations. If that's a 7x and that's a 10y, I'm going to need the 7 and the 10 to have a common multiple. And the only one that I can think of is 70. So multiply here by 10 and here by 10. And I'll multiply this by 7 and this top by 7. But the other issue is that this has an x and that has a y. So basically we have to build it. If this has a y, then I have to put a y here. Now, don't forget, this already had one. We put one here, so we have to put it at the top also. Same thing holds over here. This has going to be, it's going to be a 70y, but I need to be a 70xy. So I'm going to put the x over here. All right. So now I have a common denominator, and I'm going to go ahead and rewrite my top. So it's a 30, but it's y squared. And down here it's a 70xy. Plus a negative or minus, and in the top here we would have 63, and it would be x squared, and it'd be over 70xy. So I've got my common denominator of 70xy. I'm going to keep that. I'm going to add my numerators. Now notice my numerators has a y squared and x squared, so they can piece together, but I do not have like terms, so I cannot actually add them up and get one term on top. Someone else might have it rearranged with the negative 63x squared first, and that's fine as long as the negative sign is with the 63. Okay, so we get back over to here. Again, no cross canceling. You might want to help yourself to remember your negative signs. Again, this is going to help when you have more than one term that you remember to distribute it. And I was looking at my 8 and my 3, and I was coming up with 24. And that works because the 4. So I need the least common multiple. So what do I do to change this? Well, this has an x and that has an x squared. I know I'm going to 24. If this has x squared, then this one's going to need another x, and this is going to need two x's, x squared. So I'm going to go ahead and multiply this by a 3x and a 3x. And the 3x squared, I'm going to multiply here by 8, and that's all that one needs. And then this one needs to multiply by 6 to get 24, and I need an x squared, and same thing at the top, 6x squared. So what I have here, my first term is 15x over 24x squared. My second term is just negative 8 over 24x squared. And my last term, if you want to add the negative, is going to be a negative 6x squared over 24x squared. Now, you don't want to send yourself in a tailspin. I'll have people who will just start canceling, and if you cancel, you'll go back to the original problem. We built this up so they all had a common denominator of 24x squared. That's why we built them up. And now we need to put our numerator together. And so I was looking at my numerator, and none of them are like terms. So you could simply write this as 15x minus 8 minus 6x squared. But some of you might want to rearrange it to make it look more like a quadratic. So a negative 6x squared in standard form plus 15x minus 8 all over 24x squared. So the order of your numbers does not matter, your terms, as long as the signs are right. Now the other thing I want to remind you of, because this is a common mistake, it's something you've probably already covered, we've covered in our classes. A lot of people want to go through and cancel things. I have 1, 2, 3 terms in the top and 1 in the bottom. Unless I can take something out of all 3 terms, I cannot reduce it. So I am stuck with this. The only way I can reduce it is if I broke it up and gave them a common denominator, and then each piece reduces, which gets me back to my original typed problem. Okay, we have 2 more examples here. I don't want to say this is advanced, but it's always something that trips people up, but it's actually very simple. We have fractions, plural, divided by fractions. We cannot divide by more than one fraction. So we need to get this as a single fraction in the top and a single fraction in the bottom. And anytime you're doing division like this, the top is really in parentheses. We don't have to show it. But the top is one problem, the bottom is one problem, and then we divide. So some of you might be thinking, but the order of operations say, you know, divide before you add or subtract. This is truly one problem in parentheses, so we would do the parentheses first. So we're going to do addition first, we're going to do subtraction next, and then we're going to do division. In order to add these, I need a common denominator. My common denominator is 6, so I'm going to multiply both of these pieces by 3. And so in my numerator, I get 3 over 6 plus 1 over 6. And I'm just going to clean this up. With that, I end up getting 4 over 6. And then you could reduce it or leave it alone. But notice I'm keeping that as my numerator. Okay, in my denominator, my common denominator would be 12. So multiply here by 3 and here by 4. And that ends up giving me 9/12 minus 8/12. Okay, now once I do that, I'm going to go ahead and subtract. 9 minus 8 is 1, and it's all over 12. So you see that I am back to where we were when we were dividing fractions, right here, that we have a fraction divided by a fraction. So once I've got that simplified, I'm going to take my 4/6 and I'm going to multiply by the reciprocal of 12 over 1. Now, you could have reduced the 4/6 here. You can reduce it here. So I might say 2 goes into 4 twice, and it goes in here 3 times. Notice that the 3 can still reduce with the 12. So I can only do each piece once, but there was a leftover. All right, so final answer here would end up being just 8, or 8 over 1. Okay, so we have one more like that. We're going to clean up the top first, and that would be a common denominator of 8. Now, some of you might have wanted to jump to 16, but if that's an 8 and I can make that an 8, it saves me a lot of trouble. So multiply by 4, and that would give me 4/8 plus 3/8. Now down here, 4 and 6, I'm going to go with 12, because that's the smallest number that I could think of. So multiply by 3, and multiply by 2. All right, so in the bottom here, we have 9/12 minus 2/12. All right, so let's go ahead and clean up our top. That gives me 7/8 divided by 7/12. And I'm not going to divide. I'm going to take my 7/8 and I'm going to multiply by the reciprocal of 12/7. And so I can go back to cross canceling where the 7's cancel out, which is great. And the GCF of 8 and 12 is 4. And 4 goes in there twice. It goes in there 3 times. So my final answer is 3/2. So this is a really important review of fractions. It's also great for any standardized tests that don't allow calculators and things like that. So really important that we review our fractions and our rules. And I hope you can use this as we move into working with polynomials in fraction form.